Alright, in this video, we're going to continue on from where we left off in the last one, which was setting up to make the Vise Stop part. So, no IDs. Take my watch off. If you recall, we set our RPM. So first I check, I'm in high gear. I have to have a spindle on to turn the rotating, the variable speed head in order to set my RPM, which I did. I calculated it, surface feet per minute, or the cutting speed, times 3.82 divided by my cutter diameter. Okay, so that is all set. If you remember, I came down and locked the quill with the quill lock. And if we look at the cutter here, zoom in. You can see that my cutter, oh, no you can't. You can see that my cutter is below the bottom of my part. So that way I don't have to worry about the corners which get wore first. So as we left off, I talked about the diameter of this cutter and needing to be in the center of the part front to back when I come and touch off. So I'm going to turn this on. And I'm going to slowly move over. I'm going to see if I can get us a little bit closer on this. Because I want you to be able to see the chips. There we go. I want you to be able to see the chips and how I come in and touch off, okay? So I slowly come in. Now I'm operating by sight, by sound, by smell, and feel. I'm going to listen for a little chirping, see a chip, feel it in the handle, get close, slow. Oh, there it is. Hear it? So I go off the part into the back, nice and easy, because I was in the center and it probably didn't, I know it for a fact, it didn't cut all the way. I now have to come. So cutting from the back to the front on the left-hand side, this is conventional milling, and this is the way we want to make our cuts, because the flutes are scooping out in front. Come off the part. Now I can make a slow, now I can make a slow pass back. If I go really fast, I'll get lines, and it'll be a crummy looking finish. It'll even feel crummy. So, now I've made a pass. I'm going to go around, we need to turn it off. Stop spinning. I'm behind the part. Just an FYI, I'm behind the part, see? Okay, so now I'm going to come and I'm going to take a look at my part to determine if it cleaned up. It did not clean up all the way, so that means I have to move over. I don't want to just wheel and crank that out, so I'm going to talk to you about the digital readout. We're going to need the digital readout and use it in order to set our zero. Get you set up here. Okay, so this digital readout, so left to right, the way that we were moving in and out, which is the y-axis, we're going to move over in left to right in the x-axis, so that's an axis that I want to zero out. I've said many times in many videos previously, we want ABS, that's absolute, not anti-lock brakes. So absolute, that's up here with this button, I can change it. The other choice is incremental, and notice the numbers are nothing the same. So just make it a habit, it's absolute first. Then I pick the axis I want to zero and I press it once and again. And now it's all zeroed out. So you should remember graphing from math and a Cartesian coordinate system. So if I just set this at x0 If I move the cutter into the right, okay, I would be going in the positive direction. So I'm going to turn this in the positive direction. Now there's 4 decimal places here. We're really thinking about 3. We normally talk about 3 decimal places. That's each one of these third decimal places is 1/1000th of an inch, and I want to go 5 thousandths, roughly 5 to 10 thousandths, something like that, if I'm just cleaning up, especially since I don't know how long my part is, okay? So I want to clean it up, so I'm just going to go 5 thousandths, and I'm going to come back, and I'm going to make another pass. I'll go back down here so you can see. So, turn my spindle back on. I moved my 5 already, so now I'm going to slowly come out in Y. Nice and easy. See the chips. And out the front. The back. I'm pretty sure I cut enough this time, so I'm going to need to go way back. Turn off the spindle. I'll double check just to make sure. Yep, we cleaned up. So now you have 2 of these that you're going to need to do. So this process would be take this out, put the other one in. Now here's something you need to see. When I take this out, I've got burrs. Oh, where are we? Okay. I now have some burrs on here that need to be deburred. So I cut it. Remember before I talked about deburring? So before I could flip this around and work on the other side, because I need to clean up both sides and make them nice, and this one hasn't been done yet, I have to deburr this with the file. So that's why I suggest I do this one. I take it out. I put the next one in. Now, what you need to understand is when I put this in, I am not going to necessarily put it in exactly the same spot. And if we come up and look at how much of that cutter is hanging into the part. I mean, it's way over here. I'd be cutting off that much. So just because I put the part in, there's no stop or anything to qualify where this end is. And besides that, from part to part, they're not the same size yet. Now, FYI, this is what we're making, this stop, okay? And so that goes on here. So if I had this stop on here and locked it down and parts were the same size, I could take a part out, put it back in, and count on it being in the same spot, which is why we're making one of these, okay? So I would do both parts one end first. Call it done, okay? Take them out, deburr, and I have to deburr real quick. 45, 45, 45, 45, flat, 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 flat on the end. Now I know I'm good, and I need to make sure there's no burrs, not only for sitting down, but I'm also, because I'm working on this end, I'm going to make it the right length. Our length is 1.5 inches. So I'm going to do the same thing we did before. I'm going to come over, line up in the middle, front to back. Get kind of close, but not too close. Turn the spindle on. And then I'm going to move over until I touch. So this is side 2. Side 2. I did the first side and both parts, deburred them, flipped around. Come in and touch. I hear it. I'm going to move off. Now I know I have some stock to take off. So I'm going to go back to my digital readout and I'm going to press 0, 0. So now my X is set to 0. I'm going to move over 5 thousandths or so that I can cut it. Now here's what I want you to do, is I'm going to want you to reset 0 again so that when I'm done with this cut, we know that it's at 0, and when I measure my part and determine I have to take X amount off, I can go directly with the numbers that are on my digital readout. And I'll show you what I mean. So I'm going to move this way out of the way. Way out of the way so I can get in there with my micrometer, turn the spindle off, use the brake. Now I got my, do not take it out because it messes up the numbers. This is where a lot of students get into trouble, is they take that part out and it's no longer, the location's no longer any good. So brush off the chips, make it clean. Get your micrometer. I got a 1 to 2 micrometer because this part is in between 1 and 2. Now, I'm not so sure that you've all used a micrometer bigger than 0 to 1, but we need to double check every once in a while, and I'll show you how to do this. This is called a standard, okay? And a standard means it's precision machined to 1 inch. And so I take it, and I remember we always wipe off anvils, make sure they're clean, and then I'm going to take this standard, and I want to use the ratchet, just like always, and I want to double check and make sure that this lines up at 0. Ah, there. Yeah, I didn't do it good enough. There, make sure it lines up at 0. So this is good. If this doesn't line up at 0, you need to tell me. Okay? Trying to make it so you can see. It's got a little bit of glare. Okay? There we go. Okay? You got to see me so that I can adjust it. I don't want you to mess around with it. So, that's good. Put the standard. We got to put these little caps back on. It protects it from getting dinged up. It fits right in the case here. All right, so now I'm going to take this. It's 1.5 is finished size. Never swing this thing around. Let me move this back a little bit. I want to show you this. So I got to move a lot, and some people want to swing this thing around. Okay, but this is heavy. This is offset, eccentric. This screw that's in here that this rotates off of is precision ground. It's more accurate than the micrometer. Otherwise, how am I going to be accurate with the micrometer? So if you want to go fast, because I got a long way to go, you can roll it on your arm to open it up or to close it, but don't swing it around like a lasso, okay? So now I'm going to get in here. I'm going to wipe my part, make sure there's no debris on it, and use the ratchet, get right in here. Let me get back in here. Zoom in here a little bit. I'll try and keep my arm out of the way. Get in here, ratchet, lock it, slide it off. Now we're going to measure it. I got to get lined up so you guys can see. All right, where's that light coming from? All right, looks like it is 1.5, 25, 50, 75, and 16. 91, 591. So that means I have 0.091 to take off. Okay, I cannot take it off all at once. And because sometimes I don't measure perfectly good the first time around, I'm going to take 10, 10, 10 a few times. We'll try 15 and see how that goes. But since it's a small cutter, 10's probably a better size. So let's go 10, 10, 10, and when we get to about 50 taken off, then we're going to double check it again. We're going to double check the measurement, all right? So remember, I already set my 0 before. So now it's just a matter of coming out, cutting. Go back. Come back. So, if I thought thought I was perfect at measuring and never made a mistake, I could just go right to .091, but I kind of don't trust myself sometimes, or want to double check, because if I make my part too short, remember we have a plus or minus 5 thousandths tolerance. Continuing in the plus direction, made a few passes here. Got some nice chips. Notice my chips, they're not blue, they're not brown. They're about the same color as the material, so that means I'm not too hot. I'm going to make this be my last pass, and then I'm going to double check measuring. And when it comes to measuring or milling to length, the overall length, I can only do one part at a time, because like I said, once I take this out, it's no longer valid as far as the numbers on my digital readout or my DRO. Brush it off, make sure there's nothing there, clean. I'm going to get, now, since I'm measuring again, and I don't want to have to do math, okay? Math is fine, but if I come up with some number and I say, oh, I got to take off 37 more, then I have to look at this. Like, well, let's see what we got, and then I'll show you what I mean. So we're going to come in here, ratchet, ratchet, lock, slide, measure. I've got 1.534. So I got 34 more to take off. So if anything, I would want to be a little bit on the less side, just to give myself some leeway, because I got plus 5 thousandths and minus 5 thousandths. So do I want to do 34 on top of that number? It should theoretically come out to 91, but I don't know. So forget math. Let's just zero it out again, and now I know I got to go 34. Okay? Makes sense, right? Makes it a little bit easier. So we're going to come back down here. So technically I have 34 thousandths that I need to take off. Then I should be good. So I'm going to move over 10. So I'm going to do like 10, 8, and then, no, that doesn't make sense. 10 and 10 is 20, and then maybe 8, and then 6 for the rest of it, because that way I got a nice little small cut for last. So turn it on. I got 10 on my dial. You know what? I'm just going to go 10. Since it's 34, I'm going to go 10, 10, 4. And I'm at 20 off. $30. I gotta go to 34. Tap, tap, tap to get it there, right at 34. I'm gonna go a little bit slower this time because I want a smooth cut, and I want to make sure I don't take off more than I'm supposed to, because I'm plowing through like a maniac. Alright, get this out of the way. Notice when I brush off my machine, I never brush it off when the machine is running. Hit the brake, brush it off, get them chips out of there. Wipe, wipe. Get my mic from the bench. Alrighty, here we go. Now let's see how I did. Lock it. Nah, that doesn't feel right. Must not have it straight. Oh, there we go. That feels better. Slide it off. Holy moly, look at that. Right there. Right there. Not only intolerance, I'm just only a couple of tenths away. I bet if I rotate it up and I could see where it lines up, It lines up with, I don't see any tenths. So, anyways, I'm within plus or minus 5, so I'm good. So that's the process. Take this out because I want to show you. So now this was in the front here. If I turn it, look at the size of that burr, because the cutter was coming this way. Okay, so that's a burr. It's not too terrible. Now don't play with it because you're going to get cut. But just like always, 45. Now notice you can see, oops, no you can't, no you can't. A little bit of a chamfer there. They call that a chamfer where the edge is broke. 45. Come on. 45. 45. I already did that on the other side, so now I'm just going to hit flat. And I'm going to hit flat on the back. So now I have my Vise Stop, one of them milled to size. Okay, so again, just a refresher, we got all our machine set, all that jazz taken care of well. I'm going to come in and clean up one end, take it out, bring my other one in, clean that end up, take them out, deburr both of them, flip them over because I got to have both ends square and pretty. Then I'll put it back in. I'll mill to clean up. I'll set my zero on my digital readout. I'll come in and cut. When I make a cleanup cut that I'm satisfied with, because it might take 2 or 3 cuts, then I will end up setting my zero on my digital readout. Get this. Set my digital readout to 0, measure, make the cuts I need to make. You probably want to measure along the way at least one other time to double check to make sure you got it right. So that's milling one end to clean up first on both pieces, and then flipping it over, milling the overall length on the Vise Stop. This really relates to pretty much any project you're going to do. That you have to come up with an overall length, and most of the time you're going to mill it to length first. Okay. Now if you have to mill thickness or width, you might do those before you do the length because of having to worry about it being square. But since we didn't have to machine the width or the thickness, we could go right to the length. All right. Next video we're going to talk about milling the step that we have to put on there. Pull it out of my pocket. This step right here, these little steps right here, right there, we're going to have to mill those. Look from the end. These little steps, we're going to have to take our end mill and we're going to cut until we get that notch or step cut out. All right, and then after that, when that's all done, then we'll be able to put our holes in. Okay, all right, well, have a good one.